Hi, I wonder if anyone is up on a Friday morning watching this video in preparation for doing some work. So inverse functions, we looked at them loads last year. We kind of know they're just the opposite of a function. Sort of notation and mathematically, we might say that the inverse function is where we swap the x and the y's around, and the range of one becomes the domain of the other, and you'll know that that's goes the other way around as well. So a way of saying this in lots of different ways. The x and y coordinate swap. There's a reflection in the line y equals x. The x-intercept and the y-intercept swap. The turning point swap, if there is one. Graphically, what does it look like? Okay, going to have a little try at doing some board work now. So let's see if this works. Okay, the first thing I'm going to do is I'm going to try to draw the line y equals x. After I've got my pen sorted out, of course. So probably really useful here if you guys were to use a ruler. But I'm having a go anyway. So there's line y equals x. Okay, now I'm going to look at some certain points. This point here, point 1, 2, becomes the point 2, 1. The coordinate swap. This intercept here becomes this intercept here. The intercepts swap. This intercept here becomes this intercept here, so they swap. And this point of intersection will be the same for both graphs because they both cross the line y equals x. Now the tricky bit for me anyway, you guys might be better, so I'm going to start it. See where that one starts about there, so this one's going to start about there. Oh, bit of a dodgy start there. Oh, so I've gone through that point and curve around to go through that point, curve around to go through that point, through the point of intersection. Oh, and I want a bit. Oh, there you go. So kind of looks like a reflection in the white line y equals x, doesn't it? Well done me. Okay, let's look at how doing it using the domain and range. So here's the graph y equals root x, and here's the graph y equals root x minus 3 plus 1. So it's gone 3 to the right, 1 up. So sketch the inverse function and state its domain and range. Always put the line y equals x in. So it says here that we're going to be using the domain and range. So the domain of this function is 3 to infinity, includes 3, and the range is 1 to infinity, includes 1. So our domain and range will swap. Because of that, we could say domain of one, range of the other. So the domain here is the range of this one. So now I can put my point, so I know that it's going to, they just swap over. So I can just put this point in. That's the point there. So the point 3, 1 becomes the point 1, 3. And then I'm just going to be very, very accurate. Obviously, I'm not doing this one by hand. Looks much cooler, doesn't it? But you can clearly see that there's a reflection in the line y equals x. Algebraically, okay, well, I've just invented a new button, a new icon. So this is the pause button. So you need to pause this now and do the question. So pause it now. All right, I hope you started it again now. So here we have the graph y equals root x minus 2. So we know the domain of that is from 2 to infinity. And we know that the range of this is 0 to infinity. Now, because we've drawn the graph here, we can see that the domain and the range clearly on the graph. So you're not always going to want to draw the graph. You're not always going to have the graph. So you've got to know these things, or else it's just going to make this so tricky. So swap the x and the y around. So instead of writing y equals root x minus 2, I swap them around. X equals root y minus 2. Square both sides, rearrange. Y equals x squared plus 2. So the inverse function, f to the minus 1 of x, is x squared plus 2. Draw the graph. We can clearly see that that's a parabola. And hopefully we can clearly see that that's not an inverse function. Okay, reason being that this, if if we apply the horizontal line test, is not a one-to-one function. So because it's not a one-to-one function, it means that we can't work out the inverse. So we have to do a restriction. We need to restrict the domain of the function, the f of x function, the original function. And if you kind of look at it, it's what you have to do anyway, isn't it? You can visually look at it. Now, because the domain of the inverse function goes from 0 to infinity, the range, that should be a 2 there, shouldn't it? So the domain, that should be a 2. I'll change that later. Because the domain of the inverse function goes from 2 to infinity, the range, the domain of the inverse function, so the domain of the inverse function should go from 0 to infinity. At the moment, the domain of the inverse function is all real numbers, isn't it? It needs to go from 0 to infinity because it needs to be the same as the range of the function. So the range of this function, do apologize for that earlier on, it's early in the morning. The range of the original function is 0 to infinity. So the domain needs to be 0 to infinity. So we just need to get rid of all of this bit. So if we do that, we can clearly now see that it looks right, doesn't it? It looks like an inverse function now. So what we've done is we've restricted the function. We've restricted the function so that we can have an inverse. So there's going to be a few questions that are going to maybe trip you up like that. So an inverse function will not always exist. So here we have we kind of like think of that as the domain, that is the range. In this case, the domain will need to be restricted. So let's have a look at this. Find the inverse of the function y equals, or f of x equals x squared. Swap the x and the y. So we get x equals y squared. So when we square root both sides, we get y equals plus or minus root x, which is two different functions. It's the function root x and the function minus root x. So the domain has to be, we have to restrict the domain, so it only goes from 0 to infinity. So once we've done that, the inverse will exist. So this is like similar to the example that we just did, but working the other way around. Here in the previous example, the inverse function was a parabola, which we needed to restrict. Here, the original function is a parabola, so we need to restrict that before we can work out the inverse. So here is the inverse. This here is y equals x squared, just the positive bit. So this here is root x plus root x plus root x. Find the inverse of the function. Ooh, that's just a 1 over x graph that's moved up 3. Sketch both functions, showing the points of intersection of the graph. So the points of intersection. So the points of intersection are where they equal each other. If you think, because we have the line y equals x, point of intersection will be where all the x values equal all the y values. So that's what the graph looks like. That's example 25. So I suggest now that you work through that really, really carefully and make sure you understand how to do that. There's some work for you to do. Enjoy the holidays. Make sure you're all up to date so we can start the next exercise next term. Don't forget, do as much Google Classroom or emailing as you like. Thank you.